Hello friends, in this video tutorial we're going to look into what are inequalities. You may have been dealing with the equalities in your earlier classes and in these lecture series, but now there are certain situations where you express the domain of the function in terms of the inequalities. So let's first of all look into the simple definition of an inequality. Two real numbers or two algebraic expressions related by the symbol greater than, less than equal to form an inequality. You may have come across simple inequalities while you are arranging the two numbers. Let's look into what are different types of inequalities. The first one, the of this type are called numerical inequalities, where you have only numbers. As you have, this inequality is wrong. Okay. The next is that of the literal, which in which the variables involved say x greater than 2. The next one is that of the double inequality, which is basically inequality from both sides, like this. It can have variables also. Next is that of the strict inequality, which says that only less than or greater than signs are used. For example, y is less than 1. The next one is that of the slack inequality, in which the less than or equal to and greater than equal to signs are used, which says like for example, x greater than or equal to 0. Now we come across another set of inequalities which involve two variables. So like ax plus by is greater than c. Next is that of the quadratic inequality. It's just simply a quadratic equation written with a with an inequality sign. It's a quadratic equation written with inequality sign. So this can be of the form ax square plus bx plus c less than 0. Okay. Um, these are certain basic types of inequalities. I know this notion of getting used to inequality is somewhat not as convenient to some people as the other few chapters of this series, but I would like you to just go through these initial parts and you will be able to continue with a swifter ascent in in these inequalities. So let's first of all, in the next step, look into how to form the inequalities. If we express the quantity of number of packets of rice he bought with x, and in which the price of one packet is given to be 30, then the total amount spent by him will be 30x, rupees 30x, and which should be less than the total amount which he took with himself, that is 330x, should be less than 200. Here, less than 200. This is a simple inequality. We'll learn to how to solve it in the later part of this video, but first of all, get this idea should familiarize with how to make inequalities, which is of prime importance. Okay, next we go on to introduce what are linear inequalities. We are going to learn how to solve a linear inequality only in this video tutorial. Okay, we are not going to focus on the various other like the quadratic ones uh, as been told to you in the first slide. Okay, so the first, let's look into what are linear inequalities. If the highest power of the variable in the inequality is 1, then the inequality is linear in that variable. So you can have many or more than one variable, but the degree of each of the variable, the highest degree, should be less than 1. So in this we have two variables, which is x and y, and the highest degree of the variable x is 1 and the variable y is also 1. So basically this is a linear inequality. Okay, now we finally come to finding the solution algebraically. There are two methods to find the solution. The first one is algebraically, and the next one is the geometrical one, which we'll discuss at a later stage. So first of all, let's look into how to solve an equation with the algebraic method. Okay, so to solve the equation with the algebraic method, there are certain rules which we follow. The rules are: equal numbers may be added or subtracted from both sides of an inequality without affecting the sign of the inequality. That is, if we are given an inequality like say x plus 5 greater than 2, then we could subtract off any number or add a certain number to both sides without affecting the sign of the inequality. That is, we could subtract 5 from both sides. That is to say, if we subtract 5 from both sides, that is this, it doesn't affect the sign of the inequality, which was greater than in this case. So basically it yields us x greater than minus 3. Okay. This was a simple example on how to solve inequality. Next uh, we introduced rule 2, which says that both sides of an inequality can be multiplied or divided by the same positive number. But when both sides are multiplied or divided by a negative number, then the sign of the inequality is reversed. This idea is of prime importance. Keep the note of this property or the rule, and let's look into an example here also to get a feel of what it is. Say we are given an inequality of the form 2x greater than 4. So according to the first statement of this particular rule 2, we could easily divide 2 from on both sides, as the number 2 is positive, to yield x equals to x greater than 2. Okay, so since this number was positive, the sign of the inequality remains the same. Okay, so the next statement, to verify the next statement, let's just reverse this to get, if we take the inequality as minus 2x greater than 4. So we could divide if we divide the inequality with minus 2, then the sign of the inequality is reversed. That is to say, if we divide minus 2 from both sides, that is, if we take minus 2x upon minus 2 and 4 upon minus 2, then sign of the inequality is reversed. That is, it was greater than before and now it will be less than, to yield the answer as x is less than minus 2. It's easy to verify. Say if we have this inequality satisfied for a set of values which are less than minus 2. So let's take an example. For example, let's take x equals to minus 3, which is less than minus 2. So it will satisfy this inequality. If you put x equals to minus 3 here, you can easily see that minus 3 into minus 2 yields 6, which is greater than 4. So it's easy to verify both these rules, and it's easy to solve an inequality. Okay, so I would like you to remember 2 points here. First is the second part of this rule 2, which says that if you divide the number of divide the inequality with a non-negative number, then the sign of the inequality is not changed, and if you divide it with a negative number, the sign of the inequality is reversed. Do note this. Okay, and the second part which I want to emphasize is that when you solve an inequality, you get the solution as a set of numbers. Okay, so it'll be not a particular solution but a set of solutions. For example, here we have the set as x from minus infinity to minus 2 open. This is the set of the solution representing this equation. Okay, in unlike inequalities where we obtain only a particular solution. So let's look into how to solve a particular inequality. Okay, so let's take example of this inequality. To solve this, we'll follow certain steps. So first step would be to get uh, out these denominators. So to do this, we'll just um, take the LCM on the RHS to obtain 5 minus 2x upon 3 less than or equal to x minus 30 upon 6. Okay, in the next step, according to the rule 2 statement 1, we could multiply or divide with a non-negative number without affecting the sign of the inequality. So to get rid of this denominator, let's multiply both the sides with a number 6. So this 6 cancel out with this 6, 3 cancel out with 2, to obtain the inequality as 10 minus 4x less than or equal to x minus 30. Now what we can do is that we could add uh, numbers, subtract numbers simply. So now this reduces to sort of it follows the same procedure as doing with the equality. So simply take this 4x this side and 30 this side to obtain 40 less than or equal to 5x. And now we can simply divide by 5 so that we have the solution. Because 5 is a non-negative number, we have x greater than equal to 8 as the solution. You can easily see by putting the value of x equals to 8 in this equation to see if it's correct. So let's put the value of x equal to 8 here to verify. So if we put 8 here, just replace this x and this x with 8. Okay, so to get 5 minus 2 into 8, that is minus 11 by 3. So on the LHS we get minus 11 by 3. On the RHS we have 8 by 6, that is 4 by 3, minus 5, sorry, which yields us 4 minus 15, which is equal to minus 11 by 3. So the equality holds at the edge value, which is equal to 8. So the solution set is verified, and it will be equal to 8 to infinity, where on 8 we have closed bracket. Okay. Likewise, you can solve many more inequalities. Just follow the simple rules which we have discussed, and you will be able to solve each and every